So welcome to the session, Are You Sentimental? Sentiment analysis with R and R Studio. My name is Brian Dill, and before we get started, give me a show of hands. Has anybody worked with R in the past? Like at all? And have you ever installed it? Okay. Yeah. Installed it and actually run it. Okay. You don't have to have any experience with R for this. You're going to see code. Some of it won't make sense to you, obviously, if you don't know it. But you'll get the gist of it. You'll see what I did, and you'll be able to reproduce it literally if you just run the script, it works. And you'll be able to make some tweaks to change different content so you can do your own content fairly easily if you're a good copy and paster, like every good programmer is. Copy and paste and make changes. How many have had a copy and paste error go to production?
I fixed it last night, though.
Okay.
I really don't.
Who am I? My name is Brian Dill. I'm a DBA at Randa Solutions, the company you've never heard of. We're very small. We're an education space. I am not a DBA, I'm the DBA there. My hobby, I'm a photographer. I've probably taken your picture, and by being here, you consent to me taking your picture. I've recently gotten into drones, although I haven't done them in a while. You see my Twitter handle, my Yahoo. Yes, I'm that old. I have Yahoo. And I'm that old. I have Yahoo with 5 letters. 95, I think, is when I got it. I do have a Gmail, but this is my kind of go-to. And there's, if you care to see some photos, I have photos on Flickr, although I'm too cheap and I haven't upgraded to they changed it to where the free account only has 1,000 pictures. So every time I go, like, we're going to get rid of your pictures. I'm like, ah. Anyway. And don't worry, you won't see any pictures of my family. Those are all private. So what is R? We had a lot of people who haven't messed with it at all, and that's totally cool. This is an introductory course. R is a statistical software. Other software are SAS, SPSS. R and R Studio they're free. They're open source, and they're free as in beer. So you can literally, we'll have a link to show you where to download the R package, the R base software, and R Studio, which you don't have to have, but it's highly recommended to have. I will be using R Studio to run R. So R has data structures very much like your favorite programming languages. Raise your hand if you're primarily a .NET person. Java or other open source stuff. Any non-programmers in here? Okay. What's your background?
I've developed that previously.
Okay. So mostly programmers. So you get the gist of what, vectors, matrices, arrays. Data frames is what we're going to deal with a lot. And in my personal interest as a DBA is in data. So data frames are basically tables and lists. So these are the kind of the native intrinsic structures in R. And as I mentioned before, it is free, totally free software. It's fairly small. And I actually wanted to show you, before we get to this, and I say this is small. This is a $200 computer from 2014. It does have Windows 10. I have 4 gigs of RAM. Actually, only 3.5 because half a gig is from my video card. So I have like nothing. You see, I'm using 90%. Now I do have R open, but it's number 3 eating up. Now it will eat up more memory as you load more stuff in because R, unlike some other tools, is purely in memory a solution. So R, you're not going to do big data with R, like really big data, unless you have insane amounts of memory on your computer. So it's not useful for that, but it is useful for small to medium-sized data sets, and even some reasonably sized, because R is very efficient at memory. We're not going to get too into it, but it categorizes data if it can. So if it sees columns as male, female, unknown, it says, oh, that's a category. I'm going to make you categorical. It will, under the covers, make the lookup table, and then in the kind of, you won't see it, but in the structure, it's going to store a small numeric value to represent 1 is male, 2 is female, and 3 is unknown. So instead of having to store this big chunk of text for 1 million rows, it's just going to store a small number. So it's efficient with memory in that respect. So I just wanted to show you that I'm using this kind of POS old machine, partly to show you that you can do this with anything, and partly because this is the best laptop that I have. All right, let's go back to the slides. So where to get R? There's two things you will need. First is the actual R package, the actual engine, the guts. And this is the link to get it. Of course, if you Google it, you can find it. You can find this. And then RStudio, rstudio.com. Not hard to remember. This one's a little bit harder to remember, but if you Google it, you'll find it. The base package updates once or twice a year. Would you say, is that about right? And I'll go, sometimes a year, sometimes without updating. One little note: when you do upgrade your base R, it makes a subfolder. So any packages you installed with your old version won't be there when you upgrade. You just simply reinstall them again. Not a huge deal, but just you just make sure you need to have reinstall the packages that you need. So R is pretty bare bones out of the gate. It's very, they make it very lightweight, and they, like a lot of software like Python and whatnot, they say they want to keep the core product small and lean, and then just allow you to put packages for what you need, because not everybody needs everything. They let you just do packages to get what you need. There are, I don't know how many hundreds, thousands of packages out there. These top two are totally required for this demo. Well, a version of this is required. The tidyverse is going to be makes things easier. Gutenberger is simply just to download the data for this topic. We're going to look at some open public domain books and to analyze their data. So we're going to use basically Gutenberger for simply downloading that. Tidyverse is awesome, and this link is a link to Data Science by R, Data Science for R. I think I have it pulled up. R for Data Science. This book was written by Hadley Wickham, and he knows this pretty well because he wrote the package, Tidyverse. He knows his stuff. This is a great read for Tidyverse, and I highly recommend Tidyverse if you're interested in data in R. It's just going to make things so much easier. The other package we're looking at is Tidy Text. That is going to tokenize the text for us. I'll talk about what that is if you don't know what it is. And it provides a lexicon for us to judge words as positive, negative. So that will help us do our sentiment analysis. And that is text mining with R. I don't think this is the person that wrote Tidy Text. I'm not sure, but this uses the Tidy Text a lot in here. And if you read this and see a severe correlation with my demo today, that's merely coincidence. Analysis, I'm like, that's a really cool thing to do. It's simple. I mean, it's kind of convoluted and complex, but it's conceptually very simple. All right, so any questions so far? I know we haven't seen any code yet. What are we going to do? So what we're going to do today, and I was concerned that I would do this too fast, but I don't think I will. So we have less than 40 minutes left. We're going to download some ebooks using the Gutenberg package remarkably fast. And I have a local copy just in case the internet gods are not happy with me. We're going to tokenize the text from a handful of books into single words. So we're not going to do super complex analysis. We're going to do single word analysis. So what's it not going to get? It's not going to get something where if they said this is not good, it's going to take good as good, and it's not going to analyze the previous word saying I'm negating that word, so it's not perfect. But for the most part, you're going to get a reasonable facsimile of the data. We're going to classify the words as either positive or negative using tidy text package again. We're going to wrangle the data to get it to how we need using tidyverse. And we're going to graph the results in tidyverse using the ggplot2 package, which comes with tidy. When you install tidyverse, there's a lot of stuff in there. It takes a while to install. ggplot is one of the things that comes in there, and I believe Hadley wrote that one too. Now that one, ggplot, is a little bit old, and they're working on like a more modern version, but the ggplot2 is still very powerful. It does what you need most of the time. This video I'll post later for all your friends who want to see it but couldn't be here. All right, so that's what we're going to do, and that's the end of the slide. So now let's get into the code. So what I have open here is, now I've made this a little bit bigger. Is this too small in the back? I can make. Huh?
In the front too.
Do you want me to make it a little bit bigger? We can do that. I might have to restart R. Was it? Forget where the. If you're seeing the options or formatting, I totally forgot where it was.
I saw a zoom option under view. You can zoom in, zoom out right there. Yeah.
No, it's a Control Plus. Okay. Let's see if we can just do that. Is that a little better? One more. Well, let me get my mouse out. That'll help things along. I'm going to get this window out of the way. So we see 4 windows. Upper left is your script window, your code window. Bottom left is our console output. And upper right is your environment for any kind of variables or data sets that are in memory. And then bottom right is documentations, plots, all kind of other little stuff. You see the little tabs here. Not in the slides is almost the Control L clears your console. So you'll have to take that note. That's not in my slides anywhere. And then the Control 1 throws you back up into the script. Okay, let me make this a little bigger so we can see it. So to install packages is literally, I have it commented out, but it's literally install.packages, parentheses, and then the package name. Like I said, tidyverse takes a little while to install. Tidy text is pretty small. Gutenberger is small. And there was a dependency on this one to show you some other lexicons, which I'm just going to show you, but not going to use. And then, like most other programs, you have to reference the library you want to use to kind of bring it into this session. So you just say library, parentheses, and the name of the package. So let's go ahead and do that. So, and it just displays that in the console. So I'm just loading these packages into my session. And then just for cleanup, for display purposes, for the session, you see the upper right, there's a little something I ran earlier. If you can use the RM command to remove any object up there. You can either name it specifically or give it a list, and list equals ls. ls just says list everything that's in memory, and so this basically clears out everything. Okay, so with R, to get help, you just question mark and then the keywords. So I'm going to look at get sentiments, and like, well, if you look at the documentation in the package, that's one of the key things you will do when you do tidy text. And I'm just going to do ahead and enter. And I'm not going to make it big because you don't really need to be able to read it. Just see that it gives you a help, basically help, so you don't have to go. For some things, you can just like get the documentation right away without having to go Google it. Other times you will have to Google, and if you use R, you will be spending a lot of time on Stack Overflow because that's where all the answers are. That's where I've been doing in the past year. So let's look at, so we have the packages loaded, the tidy text, the tidyverse, and what else do we have? Gutenberger. And so I want to just show you the different lexicons. We're going to use the Bing lexicon, so let's just show you that real quick. This one is fairly simple. It's just words that have a positive or a negative association with them. One word of note, especially that's important to this analysis, because we're going to be looking at Mark Twain books. So slightly older English. Just make sure your lexicon is appropriate for the text you're analyzing. The example that was given was the word wilt. Wilt has a negative connotation today, but back in Mark Twain's day, it wasn't necessarily negative because it wasn't used like you're going to wilt this. I wilt. Wilt. It'd be as a past tense of will, but for the most part, we're just going to ignore that and just use the lexicon as is without making any changes. So if you just look, there's a bunch of words in here, alphabetical, and then is it positive or negative? How did it get this data? Does anybody have a clue how these are programmed? They're crowdsourced. So the authors, basically they put in their best guess and based on their understanding of the language and say, this word is negative, and this word is positive, and this word is negative. But then they put it out and have a bunch of people to feedback, like, you're crazy, that's not negative, that's positive. So it's literally crowdsourced. Now this is if you can see here, this is 6,000 more rows, 6,700. It's a very small subset of the English language, so we're going to be missing a lot of words. So we're only going to be analyzing the words that correspond to the data sets in question. Now, this is that's the Bing lexicon. I just want to just show you some of the other ones. So this is the AFIN lexicon. So instead of just positive and negative, this gives a rating of -3 to +3, or maybe -5 to +5, so that you can get a little bit more nuance with your analysis instead of just it's positive or it's negative. The NRC lexicon subcategorizes the words into another category. So the word over here on the left, abandon, is listed 3 times. It maps to fear, it maps to negative, it also maps to sadness. So it's kind of a taxonomy hierarchy of word meaning. And I think the last one is somewhat similar to the being, and that's just either positive or negative. Okay, so we're going to use the being, just positive or negative, just to kind of simplify things. So now let's use the Gutenberg library, our package, and we're going to do Gutenberg metadata. And so that lists, is anybody not familiar with the Gutenberg, Project Gutenberg? Anybody know what that is? So Project Gutenberg is a collaboration project to make public domain books online, accessible online. So it makes them as ASCII text. So any books that are now that are in public domain they're working on getting them available into Project Gutenberg. It's been around for a long time. I remember seeing something about them like in the 90s. So it's truncating quite a bit because I'm zoomed in, but it lists all the books that are available in the Gutenberg library currently. Now, we can't see everything here that's truncating, so I'm going to use the view command, and it is case sensitive, and that's going to list it as a kind of like a data frame in the top. And this won't zoom easily, but if you can't see it, it's just literally a Gutenberg ID, just a number for a given book, and it lists the book, and it has a few columns: author, the Gutenberg author ID, language, rights, public domain, and does it have text? So basically, mostly what we're interested in are just the book title and the ID and the author. And so I'm going to close this out and go back to the code. So that's just listing everything. So now we're going to use tidyverse package to take that Gutenberg metadata that we just saw, which is everything, and we're going to apply a filter and just select a few columns out of it. Now, for if you have a SQL background, this will kind of look familiar. The filter is basically your select statement. These are your filter is your where clause. So you're filtering based upon predicates, and the select is literally your select clause. It also has an arrange method, which is basically order by, and then there are joins. There's an ability to joins of two tables, very much like SQL. So in the Venn diagram of R and SQL, there's quite a bit of crossover, but there are some differences. So what I'm going to do, this less than dash is the R syntax for assign to. You can also use a single equals. That is valid, but depending on who you ask, generally it's considered best practice to use the old school less than dash. And it visually brings it home, because you're like, hey, this goes into here. So we're going to take the Gutenberg metadata, which is all the books listed. We're going to filter it on Mark Twain, and the column has text as true, because if it doesn't have text, I don't care about it. And we're going to only select back two columns. Three columns: the ID, the author, and the title, and assign all that stuff back to a variable called Twain Books. So we're going to run that. Now, what I didn't go over, you see this weird syntax of percent greater than percent. That is a part of a package within the tidyverse it's called the pipe command. And to understand it, when you're reading it, read that as the word and then. So take the Gutenberg metadata and then filter on some stuff, and then select these columns. So that's how you read it, in the English to make sense of it. So if you see in the upper right now in our environment, you can't see the whole thing. It just says Twain B. It's Twain books. That now holds in memory what I selected, so I can query it later. So let's just look at that real quick in the view. And so this is every Mark Twain book that's in the Gutenberg library and its ID. For those in the back can't read it, just What Is Man, Tom Sawyer, Huck Finn, some other Tom Sawyers, some of his books that you've heard of and many you have not. And an ID, and of course the author is Mark Twain for everybody because we filtered on Mark Twain. Okay, so that's too much to work with, so let's just pick a subset. How do you pick what's popular? Google. So I just said, hey, top 10 books of, and this is a little URL. All this code, by the way, is already on GitHub. I guess I should have put my GitHub URL. WBDill is my GitHub address. I'll tweet out. I'm at bdill. I'll tweet out a link to the to my GitHub. So this code will be on the GitHub, so you can take it and run it for yourself. So I said, hey, let's just pick 6 books, and most of these you will have heard of. Some I didn't, but it matters not. So we have, I just picked the actual IDs. I looked through that list and said, where is the, get the IDs of these 6 books in question. And so that's where I got these books. And this C function here is combined. So it's combined into a vector. So in other languages, you will have arrays or lists like bracket and then value, comma, value, comma, value inside of a bracket. In our world, it's C, value, comma, value in parentheses. So that's a vector of integers. So I'm feeding it a vector of integers to filter by. So we're taking the Gutenberg metadata again. I'm going to filter for the Gutenberg ID is these 6 books that I picked out. Select Gutenberg ID and title and author. So it's just now notice I didn't assign this to a variable. So this is just going to print it out. We're just going to look at it. So that's the result. 6 IDs. It's the IDs that I gave it. The corresponding titles and the author, of course, is Mark Twain for all of them. Nothing shocking here. Pretty straightforward. By the way, if anybody has questions, feel free to shout out while we're on it. If I can answer it in a few seconds, we will. If I can't, come see me. I'll ask you to come see me afterwards so that we can make sure to make it through the material. All right, so we're just looking at it. Pretty straightforward. Even if you don't know R, you can kind of see. So the N keyword has percents around it. And it's kind of funky syntax. If you've never seen it, it is what it is. Just accept it. So in SQL land, this is very familiar, right? If you've seen SQL, it's just you're aware ID is in a list of IDs, right? So there's not a lot of difference. It's just different syntax. So let's just take those IDs. And now I'm going to use a different function in the Gutenberger and actually download the data of these 6 IDs and store all the book data into a new variable. So let's just run this line. So if the internet gods are with me, we're actually going to go out to the internet, download 6 entire Mark Twain books on a really slow, crappy laptop. Boom, done. Huckleberry Finn and Tom Sawyer are not small, but in ASCII text they are, because they're tiny. So this was my backup in case internet gods weren't with me. Save RDS. RDS is our data session, our data set. I forget what the S stands for, but it's a proprietary binary R data. You can also save CSVs. You can save tab delimited, right? So you can read and write text files just like in almost any other programming languages. RDS is highly compressed, and so this was just to save it and load it back in. Let's go ahead and just run that real quick. And let's look at that. So C data R, let me look at that real quick to show you how pretty dang efficient it is. Has anybody actually read either Huck or Tom Sawyer? A couple? They're pretty sizable books, right? So 1.5 megs, 5 entire books. I was pretty impressed. Obviously, that's compressed using some sort of compression algorithm. And so if had internet not worked, I would have read this RDS into my book data, but luckily the internet gods were happy. So head, and there's head and tail. You have this in pandas for Python. You have this as Linux has this for in the shell. I'm sure Windows mimics something similar. Head says look at the first couple of rows or something, first small number of rows in the object. In this case, Twain book data. If you don't specify, I think the default is 5 or 10. Well, it's some number, kind of small. I'm going to specify. I think it's smaller. I want to show you 15, so that's why I specified 15. So we're now actually looking at the downloaded data, the first 15 lines. The first line is the int, which is the book ID, and the second line is the text. And that's it. That's all the book data is. It's 2 variables, an integer book ID and a text string. So you see there are lots of blank lines because like the title page of these books are all these line returns and spaces. As you get further down, the text gets a little more dense. But it is just like a sentence or 2 per line. All right, so there's the raw data. So there are 73,000 rows for all 5 books, and then so this if we were to list everything, we'll go to the next book ID. What's the first book? Tom Sawyer. The second one I think is Huck Finn. So there's the book data, right? It's just a basic book data. All right, here is where I hope not to, but I will lose some of you. If I do, just kind of close your ears and la la la, and you'll see the results later. We're going to do quite a bit, but I'm going to try to do it a small chunk at a time, so that you can kind of see what's going on as I'm building this query. And at the end, we're going to do it all in one statement to show you how powerful the R is, these packages are, and this piping technique that lets you do an insane amount of manipulation in a relatively small number of lines of code. It's mind-numbing at times, but it's like super freaking powerful, awesome as well. So I have the raw book data. I want to do some stuff with it. All right, it's not too useful right now. So the first thing I'm going to do is group by the Gutenberg ID, which is the book, where I have 6 books. And then I'm going to use a function called mutate, which is, I don't like the name. I wish it was something else. Mutate is make a new thing. Well, I guess mutation, like a growth, right? Make a new thing called line num and set that line number equal to row number, which is a built-in function in R, which is simply the row. Because we're grouping by first, it's going to say, for what was the first ID, 74? It's going to, each line of text will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it gets to the next book, it's going to reset at 1, 1, 2, 3, and a reset for each book. So we just get, for each book, then we're going to go 1 to n for how many line numbers. That's all we're doing here. And then we're going to reassign that back to Twain book data. Twain book data is the top one. Just trust me. It's the one with 2 variables. When I run this, I'm going to assign back to it this query where I'm creating a new one. So it'll be the same number of observations, which is observations as rows, variables as columns. So we should see 3 variables when we're done. We're just adding a line number. That's all we're doing here first. We'll run that. So boom, now we got 3 variables. So now we just have that line number in there. Cool.
Is that percent greater than percent just a line continuation?
No, it's pipe. It's pipe into the next thing. So
Take the Twain book data, pipe it into the group by, pipe it into the mutant.
right. So
Turn it to
right.
book data.
More specifically, what it does is where I have it puts it as the first parameter of the next function. So Twain book data is will become the first argument in the group by, as if I'd written group by parentheses Twain book data, comma Gutenberg ID. So it lets you change. This lets you chain things, and it's super duper powerful. All right, so now we've got the line numbers. Cool. Now we're going to do some super heavy lifting with the tidy text package. We're going to tokenize the word, all the words in the text. So we're just going to chop up each word into its own row. And so that's going to create a lot of rows, 1 row per word. So I'm going to make a new variable called Twain tokens, which basically takes the book data, unnests tokens. Word is the level of tokenization, and text is the name of the column that I'm passing in. Take this column and break it up by word. So that's what it is. So it's doing a whole lot of stuff behind the scenes. We're going to make a new variable. Boom, done. So this crappy old laptop in 2 seconds chopped up and made over 500,000 rows. And so let's look at let me just look at what that looks like real quick. Yeah. So the book ID, its line number, and then the word. So in the first line we have The Adventures of Tom Sawyer. Skip 2 lines. 3 by Mark Twain. Right. So you get the gist here. So the first line repeats a lot. The second one repeats a little bit. And then each word is its own row. So we now have like a lot of freaking rows. So now we have each word individual by itself. So at this point, we can then go back to our lexicon of positive and negative and say, hey, let's assign a positive and negative association with every word in the entire in the entire book. Now I'm using inner join here. There's left join, there's right join, which is, if you know SQL, you know exactly what that means. There's anti-join, which is get all rows that aren't in the other table, which is incredibly useful. SQL doesn't have, I'm aware of it, actual anti-join. You can say where, basically you say where ID is not in the other table. But we're going to use inner join, which is an inner join. In SQL, if you don't specify join, it's inner join. So what that means, if a word does not match, it's in the Tom Sawyer, but it's not in the lexicon, it's just going to drop out. We don't have a value for that word. We're going to just ignore it. So, and again, so we're using the get sentiments being, which remember gives us that list of words and positive and negative. And this just is printing it out. I'm not assigning to a variable, so I'm just going to print it out. And so we lost a lot. We had 500,000. Now we only have 44,000. So now keep in mind, a lot of those are repeat words. A lot of those are noise words like the, a, and that have no meaning anyway. I mean, how many times is the going to be? So you're going to lose a lot. We know this. So this is just looking at the join. So, okay, on line 15 of the first book, there the word strong appears. That's a positive word. The word triumph appears. That's a positive word. The word dismal appears. That's a negative word. That's what the join does.
Is that distinct, or are they?
No, it is not. It's not distinct. Because if the word appears 3 times, it's in 3 rows. And so because I'm joining it, we're not distincting it. Now, R does have a distinct, but I'm not using it. because I don't want to, because you'll see why.
That level of perception.
Well, we want to capture sentiment over time, over the length of the book. And you'll see the graph in a minute, so you'll see why I don't want to do that. Is most everybody still with me? Cool. Is it kind of cool, even though the syntax is funky as hell? It's not quite as funky as PowerShell, but it's pretty funky. But it's cool. It's a love-hate thing. I love it and I hate it. This is not my day job. My day job is SQL Server. And when work gets busy and I can't do any of this for a long time, and I go back to it, I'm like, yeah, I forgot everything. I have to go back and relearn it. It's just not beat into my head yet like SQL is. All right, so we're going to build on this. So I'm repeating a lot of stuff just so you can kind of see what's happening a chunk at a time. This next part, I can almost guarantee I'm going to lose some people if it just kind of ride with it. If we don't do it, we're doing quite a bit in one line, which is cool because you can do so much, but it's going to lose you if you don't. It might lose you. So the first two lines are the exact same thing, right? We're just taking that, interjoining against the lexicon by word. Now we're going to count. But what I want to do is chunk the books into a sizable, meaningful chunk. And arbitrarily, I've chosen the number 80. So every 80 lines be a chunk. And number them, I'm calling it index. Every 80 lines, so the first 80 lines are index is 1. 81 through 160 is 2. 161 through we get the process. So we're just going to chunk it up, to bundle a bunch of a chunk of the book together. 80 lines is roughly a page or two. So line number of the percent is a line number divided by 80. I think it's I don't know if it's a modulus. I forgot. It's been so long since I've done that. It does. I don't have any remainders. So it's basically, it's essentially giving us what I told you. Line 1 through 80 is index 1 line. You get the gist. And then sentiment is the positive and negative. So we're taking the Gutenberg ID, the line number, chunking it into chunks, which I'm calling index, and the sentiment. Group by all three of those, and then do a count. And so let me just show you, and it may make some sense of what's going on when I do it. So let's scroll up so you can see. Now the count, the default is the default name of the output is n, which makes sense, right? So it's n, how many? So we got book 74, index 0, negative. There are 16 words that are negative in the first chunk. In the first book, 74, in the first index, 0, I said 1, but it's actually 0 based. There are 20 positive words. Okay? Next index, next 80 lines. How many positives and negatives did you have? Next 80 lines, how many positive and negatives, right? So you see the result. So if you don't, I do not expect you to understand that syntax if you don't know R, because that's just pretty quasi-advanced. But you see the output, and you understand what it's getting at. And in 3 lines, it's pretty freaking cool, I think. So this is great. This is the data we need. It's not quite how we want to. I can't really do anything with it quite yet. However, we're going to use this other super duper cool thing called spread. Now there's an inverse of spread called gather. This does what I wish Excel could do, And if someone knows how you can do this in Excel, let me know. Because, man, I would love to be able to do that. So what I want to do is basically I want to pivot. I know Excel does pivots, but and maybe I'm just dumb. And if someone knows and tell me I'm dumb, please come up and tell me I'm dumb, and you can do this in Excel. But you can do it here too as well. When I first saw this, I was like, oh, that's so freaking cool. I want to pivot, and what I want to do is, instead of having the data like here, holy crap, I'm gonna have to go faster. I want a column that's negative and a column that's positive. Okay, so that's all I want to do. Same thing, we'll just do it. I'm running out of time, holy crap. So, book, index, just once. How many negatives, how many positives, right? So you saw what happened, pivoted, pretty cool. All right, next. We have positive and negative, let's get the net. I have 16 positive, 20 negative. The net will be -4 for the first chunk. All right, so I'm gonna do that. We're adding a new column called net. So I just added that. So now we have, negative was 16, positive was 20, so the net of +4, right? Cool. Man, I'm so sorry. Now we're getting somewhere. So now I have a net sentiment per index. And an index, keep in mind, is just a chunk. So I have a running total of how positive and negative each chunk is. So again, this is the same thing we just ran there. I'm going to join back on Twain Books by the Gutenberg ID just so I can get the book name. Instead of 74, doesn't mean a lot to me. So let's run that. So that's the same data, but now we have Twain, The Adventures of Huckleberry Finn. Cool. Nothing special there. So now we're about to get to the finale here. ggplot, we're going to run that library, or load that library, and now, unfortunately, if you're curious, I can tell you what's going on. This is obviously doing a whole lot of stuff. We're going to use a column, so basically a vertical bar graph. The facet wrap is a super whiz-bang thing, which you'll see what it does. We have 6 books. I want 6 graphs all side by side, and we'll see it. And the title is what I want to split by on my wrap, and then labs is simply labels to make it slightly prettier of the graph. You'll see in just a minute. And here's the, oh man, what's missing? Did I not? Oh, I didn't run this. So I need to, what I've been showing you all along, I need to assign that to a variable. And so Twain sentiment by index is now my data point. And so now we're going to graph that. So here's the coup de grace, or the magic. It's going to take a minute because it's a crappy laptop. It's going to be here in the bottom right, but I'm going to zoom it up. All right, so now I have one subgraph per book, and we have title as is in each of the graphs, and my pretty labels. One on the x-axis is 80 lines of text, and the number here is the net sentiment. It's a net sentiment over time. So now we can look at books, and
Explains why I've never read
Tom Sawyer is negative as F compared to Huck Finn. Huck Finn is really positive. So this is a tragedy, right? Because it ended. Look how it ended. Holy crap! Huck Finn's positive. Tom Sawyer ended positive, but man, it's negative. Now, notice how this is much thicker. The lines are much wider than these. It's just a shorter book. There are less chunks. I had Freescale X, which says just go ahead and fill it up. Otherwise, it would have lined up the scales. So if this ended 100, it would have shifted it back to line up here. The Freescale just says, hey, let the x-axis kind of be free per graph. So now we have a a net sentiment per chunk of a chunk being 80 lines of each text of these books. I was gonna get a lot of feedback from the audience to pick some other author, but we are out of time, unfortunately. Pretty cool. I have the script that you see here. Sweet. Did you already have R installed?
Sort of.
Okay.
Most of it.
I have like a condensed version of this script to show you how compact this thing is. I did a lot of repeating in this to kind of walk you through it, but to show you how much you can do in such a small amount. Now there are other you can use. So you can do Twitter. I had some stuff where you're looking at Wikipedia views, Wikipedia article views, and if you Google out there, people have done like Twitter tweet sentiment analysis over time. Like, oh, here's, this, so you can see this kind of thing, and then you're like, what happened here? Like, oh, something, you can like almost track something in the news that happened with a spike up or down. So we're out of time. Unfortunately, I'm sorry to keep you over. If anybody has questions or whatnot, I'll feel free to come up after, and I can answer your questions. WB Dill is my GitHub account. I will tweet that out. I'm at bdill. I'll tweet out your pictures to see if I've photographed you. Any questions? We have feedback cards. Please leave feedback, and I would highly appreciate just one sentence, either positive or negative, just one tiny little sentence of feedback is greatly appreciated. Speakers love to have feedback. Thank you for coming. I hope you learned something